about lesson 7.4, which is about the properties of logarithms. So just like how exponents have properties, like say if you're looking at x squared times x to the third, you have these two powers multiplying each other with the same base, then we say we're allowed to add the exponents and call that x to the fifth. So logarithms have the same thing where you can expand or condense the expression based on some of these properties. So you'll see here, like if you have a logarithm with a base and two things multiplying together, you can separate them as logarithms with that base, and those two factors are now part of their own logarithm being added together. Same with the quotient. And this can go both ways. So if I have the two factors together in one logarithm, I can expand it to be two separate logarithms. Or if I have two separate logarithms being added together, I can combine them into one logarithm where that stuff that was inside the logarithm, okay, those values of the powers get multiplied together. The same here with division, except for when they're being divided, they're then being subtracted when you separate them. Or if you had two logarithms with the same base that were being subtracted, you could rewrite them as one logarithm where those two things are being divided. And then there is a power property. So if we have the logarithm, but inside the logarithm you have a power. So you have a base and you have an exponent. That is the same thing as having that exponent out in front and then just the log of that power. Because if you think about it, let's say it was log base 2 of 8 to the third. That's the same thing as log base 2 of 8 times 8 times 8. Then by this product property up here, when you have things multiplying together, you can separate them into separate logs being added. So that would be like log base 2 of 8 plus another log base 2 of 8 plus another log base 2 of 8. Three of them because each of the three factors of 8. Now, since these are all the exact same thing, like we don't write x plus x plus x. Instead, we write that as 3x. So I would write this as 3 log base 2 of 8. Which you can see the power property just kind of breaks that down shorter and says, hey, you can do this instead of you having to go through the expansion every time. All right, so if we look at these problems here, if we want to condense them into a single logarithm, first we need them to have the same base, which they do. Notice in part A that the second term, so you have log base 3 of x minus 2 log base 3 of 7. Now, it's important that I acknowledge that there's a 2 here, so I might want to rewrite that part first and understand that that's 7 squared because of our power property. And then because these two logarithms are being subtracted from each other, that means when I combine them together, these two values will be put in a quotient. Okay? So my final answer here would be log base 3 of x over 49. You'll notice in the second one that we don't have any coefficients in front of the logarithm, so we can go ahead and combine it. And they have an addition sign there, so that means when I put these two logarithms together in one log, I'm going to take those values that were in the logarithms and multiply them. So 48 times 4 thirds, 3 goes into 48 16 times, and 16 times 4 is 64. So I have log base 8 of 64. Now, unlike the previous problem, this one's all numerical. So if you can calculate it, you should go ahead and calculate it. And remember, log base 8 of 64 is like a question. 8 to what power equals 64? And the answer is just 2. Okay? Right. Then we can do the same thing kind of in the reverse. We can expand it. So notice in this first one, the first thing I notice right away is that there's a quotient. So that quotient is going to split into two logarithms that are being subtracted to each other. The numerator here as part of the positive logarithm, and the denominator here as part of the negative logarithm. Now, this can be expanded even further. This I can actually calculate as 3. Okay? And here, this is an x times away. So this is really can be split up into log base 5 of x plus log base 5 of y. But don't forget that that entire thing was after this minus sign. So if you expanded it all the way out, that minus would get distributed to both of them. And the reason that makes sense to me is really this log base 5 of y should have a minus sign in front of it, because if you look back at the original problem, it was in the denominator, and that minus part is what's going to place something in the denominator. All right, in part B, I see three things being multiplied together, x, y, and z. So that kind of gives me the idea that I should have three logs being added together, one for the factor of x, one for the factor of y, and one for the factor of z. Now these all have exponents, so I need to use that power property and write that exponent as a coefficient multiplying the logarithm. And then notice this one right here, like adding a -1 times something is really going to make it -1. So my final answer will be 2 log of x plus 2 log of y minus log of z. Now, keep in mind that this log is not missing a base. Remember, it's the common logarithm, and its base is 10. All right, so besides the properties here, we're also going to look at a change of base formula. Now, if some of you have been trying to do logs on your calculator, you probably saw that it was difficult, or maybe you couldn't even find a place where you could type in the base of the logarithm. And now that you've learned the common log, the one that's using base 10, that log button on your calculator is just base 10. So basically, if I want to put something in my calculator, I have to use base 10, which is kind of weird. So what I want to do is think about other possibilities, which is what this change of base formula does. So if you look at the formula, it says you can have a logarithm with any base of anything. And it says that you can take that and basically it can be split into two logs that are dividing each other. One is the logarithm of the original thing you were taking the log of, and it needs to be divided by the logarithm of the base. Now, this new base, you can make whatever you want. So if I wanted to use my calculator, using the common logarithm or base 10 would be a really good idea, because then I would be able to just type it into the calculator. So sometimes that's the best idea, and sometimes it's not. So like if I look at part A here, log base 9 of 11, I don't know what power of 9 equals 111. I don't even know if 9 and 111 are powers of the same thing. So I could either try to figure that out, okay, or I could opt for like the calculator method. So I'm going to do a different method with part A than I am with part B. And obviously, if you were allowed to use a calculator, that could lead you towards one method versus if you weren't, or depending on what the numbers look like. So here, like I said, 9 and 111, I don't see an immediate relationship between them. So what I'm going to do is I am going to split them up into the two logarithms, and I'm going to depend on my calculator. So I'm going to say log of 111 divided by log of 9. Now remember, I didn't exclude a base here. Because I haven't written a base, it really means I'm using base 10. Okay. And so then I can just go into my calculator and use the log button, which is right next to 7, and type log 111 divided by log of 9. And you should get 2.143, and there's some more numbers on there, but we'll stop right there. So one method is using the calculator, and using the calculator, we usually specifically convert to using one of the buttons on the calculator, which the one we know so far is this common logarithm with base 10. Now, if I look at part B, the fact that the numbers in part B are 216 and 36, these numbers have something in common. I know that both of these numbers are powers of 6. So I don't know what log base 216 of 36 is, but if I could use a base 6, I could possibly figure it out. So in this case, I'm going to do this without a calculator. And the way I'm going to do it is I'm going to use the change of base formula, meaning I don't like 216 as my base and I'd like something else. That means I need to take the log of 36 and the log of 216. And then I need to choose a base for my logarithm. So I'm going to choose base 6, because I know those numbers are both powers of 6. So log base 6 of 36, remember, is 6 to what power is 36? Just 2. And log base 6 of 216 is 6 to what power is 216, which is 3. And so my answer is 2/3. Okay. So again, change of base formula is really useful later on when we're solving equations and we're using a calculator, like in part A. We can actually figure those out. Part B, we could have figured out with some previous methods that we knew, but seeing that those were immediately related to 6, sometimes rewriting them this way helps us figure it out faster. All right, so the last problem is a word problem related to using logarithms. So it says the pH of a substance equals negative log H plus. And some of you may have better knowledge than I do at this moment of this notation. Then it tells me what it is. It says this is the concentration of hydrogen ions. So hopefully it will tell me what that is. So then it tells me the concentration of hydrogen ions for ammonia is 10 to the negative 11. And the concentration of hydrogen ions for vinegar is 6.3 times 10 to the negative third. And then it says, what is the difference in the pH levels of ammonia and vinegar? So difference means I'm subtracting, and I'm subtracting the pH of ammonia from the pH of vinegar. Sorry, the other way around. So I have the pH of ammonia subtracting the pH of vinegar. And then I need to figure out what those are. So the pH of ammonia, according to this formula right here, means I need to do this calculation. The negative log of this concentration of hydrogen ions minus the negative log of this concentration of hydrogen ions for vinegar. So this tells me this is the negative log of, and I'm going to plug in the number that I know, 10 to the negative 11, minus the negative, so I'm going to make that a plus, the log of 6.3 times 10 to the negative third. Now I'm going to use some of our properties to figure out this calculation right here. First of all, this calculation right here, this is really a log base 10 of 10 to the negative 11th power. So if I ask that as a question, it's saying 10 to what power is 10 to the negative 11th power? So 10 to what power is equal to 10 to the negative 11th power? So when the bases match here, they're kind of giving me the answer with this exponent. So that's worth a negative 11, but it has a minus in front of it. Plus, now these are two things multiplying each other. So I can use my property to split those up into two different logarithms. The log of 6.3 plus the log of 10 to the negative third. Now this log of 10 to the negative third is going to work just like the way I calculated the log of 10 to the negative 11. So that's going to come out just to be negative 3. And this minus negative 11 is just going to become plus 11. So my 11 and my minus 3 can be combined together. So if I wasn't allowed to use a calculator, the farthest I could get is that the answer is 8 plus log of 6.3. But if I am able to use a calculator, I can go ahead and type in the log of 6.3 and get that that is 0.7993. So if I add 8 to that, I get 8.7993. So we just had to use their formulas, but we had to have some log knowledge to get through the calculation, especially if we weren't going to use a calculator. All right, so you guys go ahead and take these notes. When you come to class tomorrow, we'll be working on homework, so bring your book or pictures of the pages from the book that go with this section so that we can work on the assignment together.